For question 9c, this gets a little more challenging because we still have the same interval, 0 to 4, but we are breaking this into 8 rectangles. So the width of each rectangle is going to be 1/8 of this interval. So that's going to give us a delta x of 1/2. So I've broken this into 8 subintervals, and because this is a left-hand approximation, at the left-hand side of each subinterval, we're going to use that particular x value to determine the height. So k still goes from 1 to 8, etc. But we need to figure out what's going on with our x. So k will be 1, 2, 3, as usual, exactly what it's always been. Let's get a little more room here. 1, 2, 3, 4, 5, and so forth. Our very first x value is going to be, well, right over here, right where x is equal to 0. But then our very next x value that we're going to use is, well, it's half a unit step to the right, so that's going to be 0.5. And then for our third rectangle, we're again going to take half a step to the right. So that's at 1, then we have 1.5, then we have 2. And what you're noticing is that x is increasing by 1/2. So what we know is that this is a linear relationship, and our slope will be 1/2. So we know x is going to be 1/2 k. And then we just need to determine what we would be doing with this. So if I look at, say, this, if I take 1/2 of 2, that would give me 1. What do I need to do to 1 to make it a 0.5? Well, that would be subtracting 1/2. And then I'd check that with another ordered pair. If k is 4, half of 4 is 2. And if I subtract 1/2, again, that is going to give me what I'm looking for. Now, I'm going to write this a little bit differently. I'm going to write this as k minus 1 over 2, because I'm going to be doing a little bit of algebra with this. Okay, so we have our relationship between x and k. Step number 2, let's set up our function value, because I know I'm going to be plugging f of x in, but instead of f of x, in this case, I'm going to be using f of k minus 1 over 2. But this function that we're using, f of x, that is x squared plus 2. So let's tailor this here. So the function that we're going to be using, so f of k minus 1 over 2 is going to be k minus 1 over 2 squared plus 2. And let's do that work. When we have a fraction, we're going to square the top, square the bottom. So in the numerator, I'm going to have k squared minus 2k plus 1, but I also need to square the denominator. So 2 squared is 4. Now I'm going to add these two expressions. So the 2 over 1, I'm going to think of as 8 over 4. So in compact form, my f of k minus 1 is going to be k squared minus 2k plus 9 all over 4. Okay, and now let's go and let's set up that summation. So we're going to take the sum of all of these rectangles, 8 of them. K goes from 1 to 8. I need my delta x. So the base times the height. The base is my delta x. That's 1/2. The height, as we said, is going to be k squared minus 2k plus 9 all over 4. And for the moment, I'm going to multiply these together and pull out the denominator. So I am going to pull out a 1/8. So this becomes 1/8 times the sum as k goes from 1 to 8 of k squared minus 2k plus 9. And once again, the 1/8 comes from this. In the denominator, I have 2 times 4, so that's 1/8, and I'm just pulling it out to the outside here. And I'm going to worry about that later. So I'll have the 1/8 waiting outside. I'm going to have sigma k squared. Again, k goes from 1 to 8 minus 2 sigma k. K goes from 1 to 8 plus sigma 9. K goes from 1 to 8. Notice that I am working vertically, and you should be working vertically as well so somebody can follow your work and understand it. So now let's use our sigma formulas. We still have the 1/8 lurking outside. That's going to come in handy very shortly. Sigma k squared, well, that's going to